I'm a business development manager at Iris.ai. And on behalf of our team, I would love to thank you for joining our session today. We must admit that we are very excited about the number of participants on this call today. We appreciate your time and interest, and we also believe that we have some exciting things to show you today. So the topic of our webinar is the introduction of the Researcher Workspace and its upcoming version 1.0, which will be presented by no one else than the CEO and co-founder of Iris.ai, Anita Abelgard. Anita, how are you?
I'm good, and it's lovely to be here. Hi, everyone.
Oh, that's great. Together with Anita and myself, there's also Ada Kwiatkowska, our marketing and communication associate, who will also conduct a live demo for you. Hey, Ada, are you also excited about the session?
Hello, everyone. Yes, I'm very excited for the session. Can't wait.
All right, so do I. But before we get started, please let us confirm that you do not need to take any notes during the session. This presentation will be recorded and shared with you afterwards. If you have any questions during the webinar, please feel free to share them with us through the Q&A channel or chat. We'll be happy to address them at the end of our presentation or after the respective topic of our webinar. And this leads me to the agenda of today's webinar. The first part will be dedicated to Iris.ai's brief introduction and the company's position in the NLP space, natural language processing field of machine learning. And Anita will also walk you through the current state of AI applied to scientific texts and show you the tools of the Researcher Workspace helping our clients with scientific knowledge processing. After the live demo, as we can see, we want to share with you also some insights about our scientific approach and upcoming new functionalities. And finally, of course, as already mentioned, there will be time for your questions. I think it's enough from me, and I'm handing it over to Anita.
Perfect. I just had to go out of my browser again to have some audio going. All right. Thank you, Jan, for the intro. Again, lovely to meet everyone. And I want to tell you, as it says here, I want to talk about Iris, what we do. I want to talk a little bit of background. I'm not going to give you kind of an in-depth, presentation of AI and NLP for scientific text, but this is a field where a lot of things are happening. So, I want to give you kind of a breakdown of what we're doing, what others are doing, and what's really happening and all the exciting details. And I'll give you a quick overview of the Researcher Workspace before we dive into some more meaty demos. Quickly about us. So we are a fully cross-European startup, though we were founded and are registered in Norway. On the call today, we have people from the Czech Republic, from Poland, and from Norway living in Denmark, right? We are a good representation of the company overall. We have worked for 7 years to get to the tools that you're seeing today. We are on the very, very forefront of AI and NLP for scientific text. That is not a trivial undertaking. We've had a research team working hard for several years and research grants, etc. That technology and what we've been able to achieve so far brought us, for example, to the top 10 of what was called the AI for Good X Prize, sponsored by IBM Watson. In 2020, we were top 10 there, which was a great validation of kind of the core technology behind our tools. And then quite recently announced, as some of you have kind of ended up perhaps in this webinar because of those announcements last week, we have just been added to the so-called EIC Accelerator, which is one of Europe's most prestigious fundings for kind of high potential, high impact, futuristic, super innovative startup companies. Comes with a lot of funding and a lot of credibility, if you like. So we're very, very excited about that. What that also means is what you're seeing today, which is the Researcher Workspace, the 1.0 version, that is very literally just the beginning, right? We have massive ambition and great plans. And if we have time, we can talk a little bit more about the future too. But let's focus on the present. And one of the things that is happening right now and I see that there was a question about having problems seeing the webinar, but I'm also seeing a couple of congratulations and well done. So hopefully that means everyone is seeing it, or some of you are seeing it. Hopefully it can be sorted out for those who have problems. Maybe try a different browser. But I wanted to dive in a little bit to the current state of artificial intelligence and natural language processing for science. And I'm not going to tell you what AI is or isn't, because it's a big field, and there's plenty of opinions and ways to present it. But what I want to talk about is specifically what we talk about here, which is scientific text, research papers, patents, all of this incredible knowledge that we're building as a human species. And then we can now get to a point where we can make sense of with kind of AI machine learning technology. So we're working in this space, obviously. That's why we're here. That's why we're talking about it. On one hand, you have all the big tech players, right? You have these large language models, which I'm sure you've seen in the media lately, right? You have ChatGPT and GPT-3 and 4 and et cetera. All of the big tech players are introducing these large language models. The results can be great, but there's a couple of downsides to it, and I'll get into more detail, which is they're really expensive. And there is an issue with factuality, and I'll give you a good example of that for those who didn't catch it in the media. On the other hand, there are semi-direct competitors to us, companies of a certain size that are building very, very domain-specific solutions, specifically for, let's say, biochemistry and the likes. The problem with that is a little bit that there is a lack of interdisciplinarity. And it also requires a lot of human training to get it very specific. And I'll talk also briefly about why we believe the interdisciplinarity is important. And fact is that on this call today, there's going to be people from a variety of different disciplines. You all have your own research. And what we've attempted to do is build a tool that will work for you all, but work in detail with nuanced understanding. And then finally, I also want to mention a lot of really, really cool academic projects where you have a specific task and you do a really cool research project, and it's just not scalable to everyone else, unfortunately. And then there are other startups out there that are kind of taking some machine learning libraries and applying them and hoping that things stick. What we've done is we've done a lot of years of research to get here. I also want to talk briefly towards the end a little bit about kind of assessing quality of results, but I'll save that for later. All right, so only a couple of months ago, Meta, formerly Facebook, they put this massive language model out there. This kind of chat-like interface where you could ask any scientific question. And they said, this tool, it can summarize papers, it can solve math problems, generate wiki articles, write scientific code. I mean, it could do everything. And this tool existed for a full 3 days. And then they discontinued it, or at least pulled it back and said basically the equivalent of oops. And a quote from this article about it is that the fundamental problem is it's not able to distinguish the true from the false, right? Which is, when you deal with scientific papers, it is kind of a prerequisite, right? Factuality is super, super complicated and not something that these large language models that are trained on millions and millions of documents to generate beautiful, beautiful text, these models, like ChatGPT, like others, they don't stick to the truth. It sounds really good, but it doesn't stick to the truth. Then there's the fact, and I'm not going to go through all of this. You'll see it in the recording later. But for example, if you want to do something as simple as doing a summary, and you want to use Meta's OPT 175, it will cost you, and there's a bunch of calculations here, but it will cost you about $180. We've worked from entirely the other side with smarter models, and with our models, it costs about 23 cents. So there's also something to, balancing out massive models and this crazy investments with something that actually makes sense that people can pay for. And there's an interesting balance going on in this space right now. Another thing I mentioned interdisciplinarity, which of course is very important to us, and kind of a key premise for what we're doing in the Researcher Workspace. And that interdisciplinarity is really important. And one of the reasons for that for us is that there is indications that human beings and all the researchers in the world, that our productivity is dropping. Papers and patents are becoming less disruptive over time. We're publishing less. It takes people longer time to win a Nobel Prize. And one of the reasons that these researchers link that to is a narrowing in the use of previous knowledge. It is that simple. We have too much knowledge and we cannot use it all. And we have to make those cross-disciplinary connections. And one of the things that we're very proud of that was launched, or the paper was published just towards the end of last year, is some really brilliant researchers at CSA They were able to use our tech in essentially a astrochemistry project. And they were able to find biology articles that they normally would never, ever know how to even look at. And they were able to find new particles in space, or new candidates for new particles in space, or identifying them based on these biology papers that had to do with, cat's eyes and the like, right? And this like cross-pollination is incredibly important. So with that said, that was a little bit of the background. What we believe here at Iris and what fuels the tools we're building and the Researcher Workspace as the primary tool that we're going to demonstrate to you today is firstly that models, which is the machine learning models that lies underneath the interface you're going to see, should be at the right price and performance. It should be good enough so that it works, but it should also be affordable. Or said differently, build smarter algorithms, not bigger algorithms. There is some very, very unique challenges in building scientific applications. They're not solvable by these massive models that can do everything, although we use the principles from that where applicable. We believe that as a client, as a user, you shouldn't have to do any training. You shouldn't have to build a taxonomy of your field in order to get started. We essentially believe in plug and play. And as I mentioned, this horizontal approach, this interdisciplinary discovery is key for us. Of course, we also believe in easy onboarding of users, affordable and scalable solutions, and maybe most important of all, that results should be systematically proven. So that lies the fundament of what we do. With that, I will introduce you a little bit more to the Researcher Workspace. As I said, it's a culminated effort of 7 years of R&D. There is a number of different tools that I'll give you a highlight of, and then we'll jump into some demo examples. Obviously, we only have about an hour here, so there isn't going to be time to take you nitty-gritty detailed through everything that we do, but we'll give you a few examples of different ways of using the tools. Then we also host monthly webinars where we have the chance to go much more in depth, where we're not going to give you an intro about NLP and large language models and things like that, where we just go into the details of using the tools, where you can ask all of the questions related to that you have, especially those of you who already have access to this. So as I said, 7 years of R&D lies behind this. Factuality is the key to what we do, right? In our filters, in our analysis, in our context matching, in our summaries, right? Factuality is at the core. We also firmly believe in human-machine collaboration, which is why I will add a yet. We don't have a pure kind of you ask a question and you get the straight answer, because when it comes to scientific knowledge, the world of AI isn't there yet. Now, that doesn't mean we're not going to get there. But as of yet, there is a firm need for kind of a back and forth iteration between the human and machine. And as I said, we scientifically measure the accuracy of all of the results. And I'll show you that after we've done the demo. And these are, this is the Researcher Workspace. And again, you'll see a live version of this in a minute, but at the core is content. And what we mean with content is research papers, patents. If your organization has internal documentation that are kind of scientific, technical, R&D reports, those things. Any document that has like heavy scientific and technical text, that's what we're good at. It doesn't have to be a research paper, doesn't have to be a patent, but those kind of content collections are at the core. You can upload your own content collection in BibTeX format, in CSV format. You can you can load anything that's been preloaded into our system. So that would be open access, PubMed, US Patents Office, or you can simply connect a Dropbox or Google Drive folder with all of the amazing content that you've found in the past and stored in a folder that is getting perhaps out of hand. So any kind of these content collections can be added. And once you have the content, then you can add a variety of different tools. We're going to walk you, briefly through most of them today in our different demos. They're an explorative search. We have an analysis tool, an analysis filter. We have a summary function, and again, those summaries are a good proxy for comparison between us and some of these other players. A lot of these technologies can be used for filtering, and then we have an extraction tool as well that it helps extract factual information from these documents. So with that said, we are getting ready for demo. Now, what you're going to see live today is the 0.8 version of the tool. And I know that we said 1.0 in the webinar, and that is because the 1.0 is the next release we're doing. I'll walk you through the final features that we're going to show you that's going to be part of the 1.0. But we have that list. We know exactly what we need for the tools to be at the level of 1.0 and can be properly kind of scaled to the world. So I'll walk you through that list at the end. But for now, let me stop sharing my screen and we will hand it over to Ada, who will be doing the next part of the demo. Ada, do you want to come back up?
Yes, I'm back. Hello, everyone. So now I will show you the first part of the demo. Let me share my screen. There we go. And here you can see the Researcher Workspace. For this demo, I'm a researcher, and I want to explore a completely new topic for me, which is capsaicin, the key chemical compound in chili peppers that causes the heat, and its ability to treat the pain. So to start off, I created the open access dataset with all the open access documents that we have connected. We have over 53 million documents, and I will start exploring. And here I can choose the datasets that I want to explore within, and I can choose them from my dashboard, from all of my content. So here you can see I chose the open access dataset. I can also add some, that did not load correctly. I can also add some filters on the publishing date and including the repositories. So I found an article that I'm very interested in. It's Unraveling the Mystery of Capsaicin, a tool to understand and treat the pain. And I want to see if there are any other related papers to this one. So for that, I'm just going to copy the link to the paper and paste it here. Now the Iris is analyzing the link. It should take a second. And we'll click to create a map. So what is happening now is that Iris reads through that paper abstract that I just linked and creates a fingerprint. So it reads through the abstract, it extracts all the most meaning-bearing key terms and enriches them with contextual synonyms, and then creates a fingerprint and goes through all those over 53 million of articles that I chose and see which fingerprint of the other documents matches this one the best. And here you can see the Iris has created a map for me. Let's click here. And this is the map. So here you can see that all the documents are in these clusters. So I can click on the cluster and choose the documents that I like. And I can see the abstract and all the other information of the paper. And I can see that, some of those words are highlighted. And these words are the words that are a part of that fingerprint that Iris created. So this is a way of Iris.ai explaining why this article is relevant. And if I think that this article is relevant to me, I can click yes here. And then it will be highlighted here in my map and later in my dataset as well. I can also see the linked datasets to that map. So I can see, what kind of dataset that map has. And we have the open access dataset that I used to create the map, that I used to browse through. And I see a dataset that Iris created for me with all the articles from the map. If I want to edit the map, I can use fork a map. And here I can see the whole structure of the map. So what is behind the scenes. And here I can organize, move around, merge, choose alternatives to get the better overview of the map and also organize it the way that I want it to be. Okay, let's go back to the dataset that I created. And here it is. So this is the list of the articles that were in the map. And here you can see that's the article that I just marked in the map that is relevant. So it's also highlighted here. And I think that this article is relevant for me and I would also like to read it later. So I want to have it somewhere at hand within easy access. So I will bookmark it. And now I can find it with my bookmarks. There it is. So I can read it later. And it's still quite a lot of articles to go through and look through manually. So I want to filter it a little bit further with the Analyze tool. So what the Analyze tool does is that reads through the whole dataset of documents and tries to understand what the set is really about. So it provides us a list of concepts that are included in that dataset, and as well a list of topics that the documents can be categorized into. And then I will be able to choose from the list or write down my own concepts to filter the dataset more. Let's just give it a second more for the topic analysis. And I can find the analysis filters in the filter tool right here underneath. There we go. And here's the list of the topics that Iris decided to categorize the articles with. And I can go through the whole list and choose the ones that I think they are relevant for me and apply. And look how fast I went through 400 documents to 46 documents. Or instead of using the topic analysis, I can use the word analysis and write the concepts that I want to focus on here. And apply. Now we have 62 articles. And some of them look very interesting to me. And I think I would like to summarize them. Let me choose this one, and open the Summarize tool and start the summary. So now Iris.ai will generate a summary. I click the abstract multi-summary, so the summary will be based on abstract, but if I would have the access to the full text, I could also do one full text summary or multiple full text summary. And as Anita mentioned, the summary that Iris.ai is creating is an abstractive summarization, which means that Iris.ai actually writes its own summary, writes the whole sentences, not just copy pasting the sentences from the abstracts, and with a major focus on factuality. Let me expand that. And here's our summarization that we created. And this is one way of using the tools. And now I will give over to Anita to show you another way to use the tools.
Thank you, Lara, and hello again, everyone. So I will share my screen again. There we go. And live demos are always very fun because everything can go wrong. Let me see. There we go. All right. Hopefully you're all able to see me decently. Yes, I think so. Okay. So what Ada showed you here, right, is a very exploratory process where you don't know what you're looking for yet. You're out there to learn more about a topic, which is what the Explore tool really is built for. When you're new, when you're going into a new field, etc. So I want to show you a process that is a little bit more stringent and more kind of, well, I know what I'm looking for, I just can't find it using regular tools. So what I'm going to show you now is an example where I'm a researcher and I want to look at best practices for patient care in patients with cirrhosis. So liver fibrosis, essentially, uplifting topic for today. So finding articles on cirrhosis is not a problem, although it's a symptom related to a lot of different diseases. However, patient care is one of those things where if I'm going to write a full keyword query about patient care, I could spend probably the next, day or two just thinking of like, well, nursing, hospitals, and I have to like get a long keyword query in order to do that. So that's what I want to solve today. So let me show you how, one way I would go about that. So firstly, I'm going to add, and I'm going to do this all live. So, so bear with me. So firstly, I would add open access research articles. This is what I said was preloaded in the tool, available for everyone. This includes PubMed. So let's call this open access and cirrhosis. Ooh. Hard one to spell. There we go. So we now have an open access data set of cirrhosis, and we have about 53 million documents. So we don't show it to you here, but I want to add some filters. So first, I want to add a filter that is, and let's just give that a second to load when we have a big data set. I want to add a filter where I want to just have the more recent articles, because I want to make sure that let me do that, to make sure that we really just include recent best practices and not best practices from 15 years ago. So I'm going to apply that. So we're down to about 13 million. I want to include only PubMed in my search because let's be honest, that's where I'm going to find the best medical articles around this. So I'm going to apply that one. That takes us, of course, down to about 7.5 million documents. Then I'm going to open the analysis filters. Now, if you use the analysis filters on any of the preloaded data set, just know that these filters are pre-made because it's such a massive data set that we've kind of pre-run the analysis filter one time for this whole kind of 53 million articles. So otherwise, it would take you a few days to do this. But these will show up directly here as filters, the same way Ada did for her kind of 400 document set. I can now do for this document set of 7.5 million. So what I'm going to do is I'm going to select a couple of topics. These are topics that are, generated from all of these 53 million articles. But we have a couple of kind of main topics in here, which is, health, patient care, etc., which seems very relevant, and treatment, treatment, patients, disease, etc. Each topic here is represented by a string of 10 words. And that's sometimes in human-machine collaboration, getting the machine to explain this to the user in a way that makes sense. It takes a little bit of practice to get used to how the machine speaks to us, sort of speaks for those who are not used to things like topic modeling. But I applied these two kind of topics. We see that 1.7 million articles falls into this one, 3.57 in the other. And then, of course, we want to add our kind of main topic right now, or main concept, which is this condition of cirrhosis. So with that, we should get this data set down to something that I would call manageable. Now, not everyone would agree with me that that is a manageable number of documents, but it is manageable for the machine. So we are down to 9,800 documents. This is manageable for the machine. So what I'm going to do now, right? We've gone from 53 million down to about 10,000, and we can see here, all these articles now are quite related to cirrhosis. And of course, there's going to be some noise here, right? But this is really the data set I want to work with. And in some ways, this isn't that different from doing a search in any other database. But what I'm going to do here is I'm going to make a data set that is PubMed cirrhosis. And this is kind of where we can really get to, let's call it the magic of what these tools can do. That is different. And I'm seeing that I have a little bit of poor connections. I'm hoping you can still all hear me. If not, maybe Ada and can jump in and let me know. But we are now making, and as you can see, as you saw with Ada as well, we have notifications of everything that's happening. So okay, you can hear me fine. Perfect. Thank you, Laura. So the workspace is now making a new data set for me that in one way is a clean data set with no filters, but only these 9,800 articles. I'll give it a little bit of time. There we go. As you understand, working with tens of thousands of documents at the same time, there's always a little bit of lag in everything. So back to what we were doing. So I have this new data set. We could use the analysis tool, same way Ada did, on this data set to kind of map it out. However, it would take about 20 minutes. So I'm going to save you looking at that. We don't have time for a coffee break today. Otherwise, that is what I would do. But you could use the analysis tool and run that. However, what I'm going to do is I'm going to focus first on the context that we're looking for. And as I said, the context here is patient care, right? Something that is ridiculously hard to put into a keyword query, but really easy to describe to a friend, right? Or a colleague. So I've made a filter. Now, these context filters, these you write yourself. They can be 50 to 100 words, description of what you're looking for. You don't have to worry about using the right words that other researchers might have used. Just use your own words. You can add a new filter like this. Now, I've already tested what I'm demoing, surprise. So I have a saved filter here that is called patient care here. And within a few seconds, the tool is taking these 9,800 documents and matching it against a description that I've added of patient care. And if I can show you that description, it's quite simple. Patient care refers to the prevention, treatment, management of illness, et cetera, right? It's a short, sweet definition. I will admit that I copied this off the internet, right? It's a very simple thing, but I'm going to use that to match against this. And what I found here was a patient care match of 50% was a very good filter here. Now, as I said, in our original data set, there was a little bit of noise, right? We really just filtered on cirrhosis as a concept. So for the sake of having good results here without having run the analysis tool, I'm also going to add a filter for liver fibrosis. And here again, it's a context filter, so it's just a description of liver fibrosis. Again, here you can see kind of a quick medical description. And I'm going to set that, I found 55% was a really good way to do that, or a good measurement. This is, again, you kind of, this is more art than science, right? To try the right context filter setting in this context. So anyway, we applied that. And we found about 310 documents at the end. So what I'm going to do here is I am going to sort this by the match score with the context filter of patient care and the match score of liver fibrosis. And then in this, and you can see the scores here. And now if we look at this list, right, we're going to get, palliation in end-stage liver disease, a nurse-led clinic for patients with liver cirrhosis, nursing assessment tool, palliative care, how we utilize healthcare resources, health literacy levels, etc. Everything that has to do with the thing that was so hard to put into a keyword, patient care, we have right here. And we have about 300 documents. I could, of course, continue adding maybe a third context filter, or I could save this as a new data set. But I think you get the point, right? Here we have very, very quickly a data set that has 300 articles spot on without me having to spend any time on kind of mapping out a big keyword query on something that is very, very hard to define. When this is done, you can export this as a CSV file, EndNote, BibTeX if you have a preferred reference manager. We're not really attempting, at least for now, to be a reference manager tool or anything like that. So you can always kind of export into your preferred system as well. That is that I wanted to show you. That is a very different approach than Ada showed you with the explorative search, right? This is much more, I know what I'm looking for. I just don't have it in me to try to make a keyword query for it. That is that. The one final thing, actually, let me share my screen one thing, because it was one final thing, and we're not gonna really demo that today. But I did want to show you, we do have a collaboration feature as well that is brand new. So anyone who's in the same organization or with the 1.0 that is in the same project, but not necessarily in the same organization on Iris, you can collaborate on projects where you can share data sets, you can share filters, you can help each other, you have access to all the same things. So this is not just a one person operation. So we do have that as well. All right, so with that, I will leave the word over to Jan, who is demoing the last tool for today, which is the extract tool. After Jan is done, we will kind of have a quick walkthrough of a final couple of points on how to get access to the tools and what happens with the 1.0. And then hopefully we have time for 5 to 10 minutes of questions. I see we have some questions here. So I'll leave it over to Jan.
All right, thank you, Anita. So let's discuss right now another hard topic, not capsaicin and cirrhosis, but it will be heavy metal, it will be steel production. So let's have a look at some use cases related to data extractions. Let's assume that I'm a member of the IP analysis team, and after conducting my prior art search and identifying similar patterns using the Explore and the analysis tool that you've just seen, used by Anita and Ada, I want to extract certain data from this data set of my patterns that you can see here, for instance, on the subject of steel material. And first, let's start with a simple extraction project, such as collecting the desired metadata from patterns. What I'm going to show you is one example of the pattern. Well, it's not the lengthiest one, it has some 70 pages, but for my analysis purposes, I would love the machine to collect data like date of publication, application number, date of filling, assignees. But besides that, also other information like if I'm scrolling down, page number 13, if I'm not mistaken, I will have to capture also the claims. And this everything systematized in one table that I can review afterwards. So what can we do about that? If I'm going back, I beg your pardon. If I'm going back to the Researcher Workspace, here we go. Just a second, please. It's strange that's not there. As Anita mentioned, it's always fun when you are doing the demo and you get lost there. But nonetheless, that's our reading list I wanted to share with you. And our goal is to select this patent that we have here. So let's check this off. I will apply the extract tool on that. So here we go. Then I will generate the extraction, which means that I will select my spreadsheet where I would love to collect and gather all this data. It's called patent. It's by default in the Researcher Workspace. I will call it like metadata extraction. Here we go. And it will be processed. It will take some seconds to be done, but for the sake of time, we can have a look at this metadata extraction. Once it has been processed, you can download it over one click. So let's do that. Here we go. And we wanted to show you how it looks like. So here we go. My goal was to capture data that cannot be easily captured by citation reference managers. So for instance, what we already indicated, patent number, issue date, expiration date, and so on. But of course, also the claims I wanted to have covered in my spreadsheet or populated in my desired outcome. It can be also database. That's the, let's say, the simple example of patent extraction. We can have a look once again at this particular patent, and we will see inside also some tables, right? That's probably no wonder. We can see tables in other documents like research papers, clinical papers, internal documents as well. The case number 2 is the following. We can find these materials, in a variety of documents already mentioned, but we were asked also by our users that they should be able to extract this information and to let the machine detect the tables and extract the information for them and systematize them in a CSV file to save their time. So it's a feature that's going to be implemented, table extractions, and the machine will recognize all the tables in the selected PDF and export them into the CSV file. And finally, here we go back to our reading list, right? And let's review once again the same patent because there are information scattered around the document. Actually, it requires a lot of concentration if you want to connect the data that's in the text, in the table, in chemical structure, in captions, and to find the contextual understanding and correct linkages between the data. So what I wanted to show you next is something we call output data layout. In other words, it's a machine readable spreadsheet that is created by you or together with our team to indicate what data you want to have extracted from the documents. Again, this can be a patent research paper or any other type of internal document, like a quality report. So we can see here listed some variables and quantifiable properties I need to detect across the document. And let's have a look. Some of those are like chemistry table, like we can see carbon and so on, these indications. Also the units, I would love to capture it in percentages, these data points, these data ranges. Let's have a look components, for instance. This is just an example, but for my case, for my IP analysis, this is the data I would love to capture and collect. Maybe interesting thing is properties. So for instance, tensile strength, cooling temperature, and so on. Our goal is to capture different kinds of units, data points, data ranges, and also some named entities like the type of coating process or type of product, and so on. So let's have a look at the outcome. And I'm back here. Again, I will choose the same patent, right, that we have worked already with. Let's apply the extraction to that. Now I will select a different spreadsheet, ODL, output data layout, which will be related to steel. We can call it like steel extraction. Here we go. And again, for sake of time, we can have a look at the extraction, how it looks like. So again, you can extract this information file by file or in a batch, which saves your time. And here we go. Let me open the file. All right. And there we go. I will make it a little bit bigger for you. Hopefully it's visible. All right. As we can see, all relevant data points found by the machine in this document have been associated with the respective columns, and more importantly, also with the respective rows, corresponding rows. So what's important here to highlight, the machine is smart enough to identify these linkages, these connections. Like for instance here, there is a table number 1, which is referring to table number 2. And that's why all these data points are connected together and systematized in one row. Just for your reference, that's maybe for the sake of time, I would love to show you information related to some of these categories we discussed, like tensile strength or cooling temperature. You can find here also information related to product type and so on. So basically, this is a project-based extraction where you need to process more than 10 documents, probably sometimes thousands or hundreds or tens of thousands, and the machine can help you with the job to have it done with a human level accuracy and very quickly. So that's from my side related to this third scenario, and I will hand it over back to Anita.
Perfect. Thank you, Jan. And hello again for the third or fourth time, everyone. So I do have a few more slides. I will try to keep them very, very brief, just to have time to answer your questions, because I saw there were quite a few questions there. So let me share my screen. I did mention that we measure everything that we do. Outside the scope to go into detail of this, but we have ways to measure the exploratory search, where we've done kind of a comparison between humans and humans plus machine, essentially. With filtering and extraction task, we can measure things like precision and recall, as in how much did we include and how much did we miss out on, and of course, time savings. And then for summaries, abstractive summaries are notoriously hard to validate for factuality. One of the things is that we are using a context similarity, which we call wisdom, which is one of our algorithms, where we compare, is the fingerprint of the full article similar enough to the fingerprint of the abstract or of the summary, or has the machine what we call hallucinated? This is one way to do this. But this is just the start, right? So we have a lot of research projects in the work on this front, because we do think not just for summaries, but for everything we do, factuality checks is and kind of sticking to the truth and not allowing the machine to hallucinate. And for those who don't know the AI field, yes, that is actually what you call it. You call it hallucination when they make up their own facts. So this is something that we work very closely with. I mentioned the 1.0. It's coming very soon, within about a month, give or take, for those of you who know how it is with software. What we're introducing is Boolean logic in the filters, especially in the analyze filters. Some things like merging data set, editing your problem statement, sharing of projects outside the organization, table data extraction, like Jan mentioned, some more tutorials to help you navigate the tools, a better performing summary engine, and in general, just speeding up things and all the things that you do for a 1.0 version. So this is what is coming, and at that stage, this tool is at 1.0. However, we are already onboarding clients, and we have many people using the tools already. I did see there was a question about academic and student pricing. In general, I mean, we can talk to you individually if you're curious about this, but we're working with very simple, scalable pricing. where it's per user seat. If you want the advanced extractions that Jan talked about, that is more custom work. So then we have kind of batches of documents that you can basically buy access to 1,000 or 10,000 extractions, depending on your needs. They require a lot of computational power. But basically, that is the pricing. We have academic discounts for anyone employed at a university. We also have student discounts on top of that. We try to help students, PhDs, masters, to even bachelor's degrees, to get access to tools that will help them with their academic careers. That's briefly about that. And then I did see that we had some questions. So let me jump back to the screen so I can see them all. I'll just take a few questions. Samir asks if Iris works only on scholarly content. It works on scientific and research style texts. That means if you have a collection of very scientific, popular science articles, you can upload them. The further you get away from the language of a research paper, the less we vouch for the results. If you upload, a bunch of documents of Twitter messages, we cannot promise anything. But yes, we can kind of expand beyond just like the pure scholarly academic format. But again, what we're good at is the technical and kind of scientific text. There is a question about the databases, how often they are updated. So for the ones that are there, the open access, PubMed, US Patent Office, they are updated continuously, which actually allows us, and this is a feature that's not yet coming, but it's coming after the 1.0, which is adding in. So let's say that my cirrhosis search, right? It yielded me this document set of 300 and something articles. I could, or I will be able to, within, short, it's quite high up on our priority list. I will be able to click, essentially, let's call it subscribe. So I will be able to get notifications whenever something that matches my context filter, matches every filtration that I did in the first step, that has been added to the starting point, which was the open access articles and PubMed. I will be able to be notified when that happens, right? And it's a somewhat complicated thing to do, and it's computationally intensive, but that's what we want to do. So that is a feature that will be coming. And when it comes to loading in the open access data set, yes, that is updated on an ongoing basis. With regular intervals, at least. Don't expect maybe kind of daily updates, but it is being done on a regular basis. Let me see. There is a question from Samir again. Thank you for all your questions, Samir. Can I instruct? Let me highlight it. Can I instruct Iris to bring only highly cited paper or high H-index? That is. Oh, we could have a lengthy debate on it, because I get why you want it. At some level, it also goes against what we fundamentally believe, which is, I think it's the three most cited papers. I don't know if it's within the NHS structure or however it is, and I'm sorry, I can't give the right citation on this, but like the three most cited papers are all sort of debunked later. But they're the most cited papers because they're the most cited papers because they're the most cited papers. So we want to be very cautious with it. We are not baking that into any of our algorithms, because I have been quoted saying it's more of a popularity contest. So we're not baking it into our algorithm. With that said, it is metadata, right? And if our users choose to use that metadata, we probably won't stop you. So it is on our list. It has been requested before. We're just a little hesitant in bringing it in because that's not along the line of what we're trying to achieve. So maybe as a metadata filter in the future is the kind of the simple answer to that. You also asked if you could import data sets from Dimensions, and as far as I know, exporting a data set from Dimension means that you'll get it in a CSV file, so that should absolutely be possible. If you have a CSV file, you can import that, and then you have those articles as your starting data set, or one of your starting data sets. You can merge them and combine them as well. So, so the answer is yes, you can import data sets from Dimensions. I think we mentioned this during the demo as well, but yeah, we can also summarize full text articles, but we do have to have access to the full text article, right? So either it has to be open access with full text, or it has to be something that you've uploaded yourself as a PDF, or you know, in some ways given Iris access to the full text. That means, you know, I wish we could solve for just making all research open access so that it's all there, because I do believe that the world of science would benefit from that. We're not quite there yet. So until that happens, it's kind of up to you as the user to get access to the full text. And yes, then we can summarize full text. Let me see what I think. Yeah, so Tim has a great question. If you upload results from your database search into Iris, so yes, if you do a you know, a search on yeah, whatever, Embase or something, and you take those articles and you upload them to Iris, they only exist for you, right? So we are in some ways, you can think of our platform solely as the intelligence layer. All of the research that you find in the preloaded data sets, they don't come from us. They're hosted somewhere else. Your data set stays private unless you choose to use the collaboration feature and share it with someone. So there is no data of any kind that leaks to other clients or users. So you know, you can upload things that are paywalled, that only you have access to. You can upload internal documents. We abide by very strict security and privacy regimes. So we keep them safe, and they're only yours. Yes. And thank you for all the good questions, everyone. We only have a few more minutes. Paulo asks about the European Patents Office, and that is. Let's see where we have it. There we go. I'm going to highlight that question too. I love the highlight feature of this platform. So yeah, we want to integrate the European Patents Office database as well. Absolutely. So that is also coming. And by the way, thank you for all these questions, and which in some cases becomes feature requests. We do keep an ongoing list of feature requests from all of our users, and right now that includes you, even those who don't have access to the tools. So these things are all being noted down if they're not on the list already, or just upvoted for those who are already on the list. So for example, the European Patent Office. So yes, that will be added in the future. It is not yet added in. Let's see if I have any other question that I think we should definitely respond to. I think we are now at a minute to the hour. So let me just check the chat. So yeah, so there was a question about contacts, and the contact details for the three of us is pasted in by Ada in the chat. So you have that there. And yeah, and finally, if you want access to this, the easiest way is to email Jan. I know there's a link on our website that is sign up. That is to our legacy tools. So that sign up button, until we reach 1.0, which is within a month or two, that sign up button will take you to our legacy, kind of our old tools, and not to our new Researcher Workspace. So the way to get access to the workspace right now is to email Jan at Iris.ai. And then we can talk about how to get you access. We do have some beta kind of tester opportunities, but we also have kind of commercial opportunities. And again, we're giving, we make this cost efficient, both for corporates, but especially then for students to make it somewhat affordable. finally, a question, Samir, about investments. We can take that offline, and we can have a chat about that separately. That would be an interesting conversation, because that's a bigger topic for a personal conversation, I think. I think that was it of questions. Thank you for all the kind comments during the presentation. We appreciate you all coming. And we're really hoping to see you all in the future as users, as collaboration partners. If maybe one final thing is, if you are an academic researcher and you have some kind of project that is tangential with NLP and AI, like CAS at Clay, we're also very open for academic collaborations. We have a lot of academic partners like UCL and Rice and Open University, etc. So we would love to collaborate with more people. Thank you, everyone. Thank you, Jan. Thank you, Ada. Jan, any final words from you before we wrap it up?
Yeah, thank you to everyone for joining our session. We believe we have almost record number of participants, at least over the last 3 years. So we really appreciate once again your interest, and we will follow up with you. As promised, you will receive the recording, and some questions that we did not manage to answer today, you will receive the answer afterwards. So we'll be happy to stay in touch with you, and have a lovely day and great week ahead.
Thank you, everyone. Bye.
Bye-bye.
Bye. Have a good day.